Alright, so we continue here now from the last video. Now, what the angle? What is the angle? We want this little angle here. This will be the angle to the horizontal. Call it alpha. So we can use tan. Right? Tan alpha equal opposite 0.672 over adjacent 8.8902 equal. So we can just say tan inverse alpha or we don't have to do all of this. We can say alpha equal tan inverse of this and just do it one time on the calculator and done. So if we go to the calculator now and we deal with this, what we can say is 0.672 over 8.8902 equal 0.075. And then we say tan inverse of that equal 4.32 degrees. Now that 4.32 degrees is to the horizontal. Now here, if we consider it as 4.32 degrees to the horizontal, right? Then that angle now, what we found earlier, we're looking back for what we found earlier, it's 4.32 degrees to the horizontal, right? Now, is it going up or down? The angle of the angle of the resultant. This, oh, it's going up, you know, I draw it wrong. This is a positive. Mistake. I drew it wrong, even in the last video. It should be like this, my. I draw the thing wrong. It should be upwards, because it's a positive. Right. So, here. It should be like this. It should be 8.8902I and 0.672J upwards. Right. So that is what you really should have. Alright. So this angle is a 4.32 degrees. Alright. Now, what's the angle from A? Earlier we got 25.67. So let us see if that really is so. If we have the angle of the resultant to be 4.32 degrees here, then this angle would have to be 30 minus 4.32 degrees. Let us calculate that. 30 minus 4.32 degrees. So 30. Oh, let me just get back the 4.32 degrees. 30 minus that equal 25.67. or 6, 8. You get back the same thing. Now, the thing is this. About 2 videos ago, or 3 videos, 2 videos ago, we use the sine and cosine rule and dealt with it. Then, in the last video, instead of using the sine and cosine rule with all of these angles, we broke up each vector in the horizontal and vertical component. And we see that we did not have to use the sine and cosine rule. So that is one good way to add the 2 vectors. Break them up into their horizontal and vertical component, combine all horizontal and all vertical components, then put them back together, and you get the resultant. Alright? So, as a summary, what you do? You have 2 vectors to add, right? You have them at an angle to the horizontal. This is the horizontal. You break this up into its horizontal and vertical components. You break this up into its horizontal and vertical component. So you have, call this vector 1, vector 2. Alright, call it V and this W then. No, not V and W, because we're using vertical and horizontal. Call this A and this B. Alright? So, this is I for A and J for A. You find that. You find those. Alright? As for the B, you call this I for B. Oh, IJ. Wrong thing I do. I is horizontal. Is I for A and J for A. Alright? For the B, this length is I for B, and this length is J for B. I for B, J for B. You find them. Then you add them. You have the I for A, you add it to the I for B. Then you have the J for A, you add it to the J for B. And what you have at the end is the I, or the horizontal, for the resultant, and the vertical for the resultant. And finally, you can calculate the magnitude using Pythagoras theorem, and you can find the angle using trig ratios. Alright? So, adding 2 vectors, once you have them at an angle other than 90 degrees, it becomes complicated, so that you have to use sine and cosine rule. You can just break up each vector into horizontal and vertical components, put them together, and then you don't have to use any sine and cosine rule. Alright, so that is it for now.